Recording. All right, so everybody say hello. Hi. And then we'll try. Okay. First slide. We will get through the atomic theory today for sure. Isotopes quickly because you already know how to do that. So atomic mass, you do know how to do, but we're going to talk about mass spectrometry. We're going to watch a video link for mass spec, and I put the link already into the Google Classroom. So if you want to watch it again, it'll be there for you to check. And then mass percent, similar with the mass spec. You're going to learn a few new details there. Oh. Why is there a decimal there? Why is it not 109? Because it's relative to what? Carbon 12. Get it? So since this weighs more, right, we're scaling this to carbon 12, it's not just going to say silver is 109. And this isn't just going to say silver is 107, right? Because it's relative to what carbon was as 12, carbon 12. All right, so now find the mass of silver 107, the actual mass of it. So here's your general equation here. You're going to take these masses and you're multiplying them by the abundance as a decimal. So divide that abundance by 100 because this says relative number of atoms there, it's showing you. And if we look at the relative number being out of a total of 100, we would divide by 100. Then you add your next one, your mass times the abundance divided by 100. And then you would do it again and again and again for every isotope that you have. Say we only have 2, like in this example. What does this value give you? What does this all calculate to give you? The average atomic mass. That comes from the periodic table. So get your periodic tables out. And now this is a simple algebra problem. So I'll do this one with you. So what you should see in your next slide, I believe, I don't have it in front of me, is it an empty box? Yeah. Right, so now you're going to start doing the math with me. So I usually do the one example problem with you, then there might be a second example problem that you would do on your own. All right, so first step. It's not loading. There it is. All right, so notice I have my mass, and I'm going to look back at that graph, and I find the mass of silver 109. That's what that one is for, silver 109. And it tells me that it's 48.16. What did I do? I converted that to a decimal, right? So just divide it by 100 or move your decimal 2 places to the left. And then I'm adding to that the mass of the unknown, which is silver 107. I don't know that mass. And the percent abundance of that was 51.84. Divided by 100. And then where do I get 107.87 from? Periodic table. Big rule right now, when you use your periodic table for the AP exam, you must use all the numbers on that periodic table. When you took honors chem with me, what did we round to? The first decimal place. In AP Chem, you use exactly what's on that periodic table. They already rounded it for you. So you're going to use all the numbers that they give you, and then you're going to take sig figs at some point from those numbers and what you're calculating. Okay? So go ahead and solve algebraically now for this. Always, yep. You always will use your calculators in class and on your homework. You just need to mentally be prepared that you may get a question that you'll have to do mental math for later on. And I always give you a set of multiple choice.
Catching 40, 16 again?
Because on that graph, it said that it's 48.16% abundance. It said relative abundance was 48.16. You add up 48.16 to 51.84, that gives you your abundance of 100. So that's why we're taking it out of 100 as a decimal.
And 107 AG.
That was given, that one is what we're solving for.
So it would be like the X variable.
Yep, that's your X. All right. So you should have calculated now 52.45. We rounded for sig figs because there's only 4 sig figs there. And then that's plus x times 0.5184 equals that. So now you subtract out your 52.45. And now you have basically 0.5184 times x is equal to 55.42. And then divide that by the 0.5184. Just algebra. And so your mass is 106.9 atomic mass units. Where did the 4 sig figs come from? The abundances. The abundances only had 4 sig figs, right? The masses were much more. Questions? All right, so moving on. Anybody not get this? So this is a really good number, but from the information that we had, we could only use 4 significant figures. The actual mass does carry out to more decimal places, but we're just going to use sig figs appropriately. All right, the next one, you try this now on your own.